Hey, let me tell you something about the domain and range of functions. Hopefully you remember from earlier in Algebra 2 or maybe another math course that domain are the x's of a function, and we call the range those are the y's of a function. When we did this last semester or in an earlier class, first we looked at just a set of points. Here's my set. Three, 4, -2, 6, 1, 2, -6, and -4. So the domain, we just call that a D, would be all the x's, and we should write those in order too, from least to greatest. The smallest x is -6, the next one is -2, then 1 and 3, and you close that with that little thing. The range is all the y's, those ones are left over that we haven't used. The smallest one is -4, next one is 2, next one is 4, next one is 6. But what if we have a function, in this case a quadratic, because that's what we're looking at. Let's pretend we got a parabola with its vertex, the minimum point right there at 0, 3. The domain in this case, all the x's, if I had x's down here, I could choose anything coming all the way out here and have a point. So the x's are everything. We call that all real numbers. When we're thinking about sets, all real numbers is negatives, integers, decimals, fractions. I could choose anything along here. We write this in what's called set builder notation. We had done a little bit up here with that thing, but when we're talking about domain and range, we have to add a little extra element. Domain is x's, so we'll put an x. We write x, and this line means such that. So all values of x such that x is part of real numbers, that set. We have that poster in the classroom. And then the last thing they do is they put this little e here, which means it's an element or a piece. So the way we read this is all values of x such that x is an element of real numbers. Okay, so we have domain. Let's look at range. All the y's that work for this is everything that's above the vertex. Everything from here up. Since that vertex is at 0, 3, and it's an upward facing parabola, the range is going to be everything above the vertex. If we write that in set builder notation again, it's going to look like y, because we're looking for range. All values of y such that y is greater than 3. That counts for the everything above. And then it could be 3 also, so we say greater than or equal to 3. So if you're looking at a graph, that's how we can look at domain and range. Another thing to remember is the domain of a function is always all real numbers. If you just have a normal equation. There'll be some special cases, but just a regular old function, it's always going to be all real numbers. You can put that in right away. Let's look at one example from an equation. Let's say maybe negative x squared plus x minus 2. Just a quadratic equation. The a here is negative 1. The b would be 1 for there. The c, or the y-intercept, would be negative 2, right? Thinking back to what we did before, remember we defined the range from the vertex. So what we need to do is find the vertex with our equation. First you need to use the axis of symmetry. That equation is x equals negative b over 2a. Substitute in what we did before. So x is going to be negative 1 over 2 times negative 1 for the a and the b. Simplify that. Negative 1 over negative 2, or half. So there's the x. And we get the y by plugging back into here. So y is going to be negative half squared plus half minus 2. Square first, following your rules of exponents. Half squared is not 1, it's actually half times half, which makes it 1/4 plus half minus 2. Last thing, put these all together. Negative 1/4 and a half is the same as half minus 1/4, or just 1/4. And then minus 2 is going to leave us with negative 1 3/4. If you were to make these decimals, I think it would have been a little bit easier to know that that was going to be negative 1.75 if you would rather do it that way. Our vertex then, there's our y, here's our x. Let's write these just both as decimals. Half and negative 1.75. If you were going to write the domain and range of this now, your domain we wrote on the last page is all real numbers, because it's just a regular function. And your range is all values of y, such that y is, now we know we're going to have 1.75 in here, because that was the y of our vertex. But we need to think about if they're going to be greater than or less than. So we need to kind of think back to our graph. You could do this in your head, maybe not so much write it out. Because a is negative right here, that means that our parabola would be downward facing. So all the y's in the range are going to be from here down. If we're looking at things that are lower than a point, that means we're doing less than. So the range is going to be y is less than negative 1.75.